To continue our journey in preparation of applying reliability-centered maintenance methodology and selecting our maintenance tasks, as we had explained in the previous two videos, we need to understand why the RCM is not focusing on failure prevention. So why failure prevention is not in the main focus while we are preparing our reliability-centered maintenance. Even for some conditions, it allows equipment to fail, and you can simply say there's no planned maintenance activities, there's no visible maintenance activities, there's no scheduled maintenance activities that we can do, and we will let this equipment fail. So this mentality or this methodology of thinking is not common when we are setting up our maintenance, because usually we are used to prevent failure. So we usually say that the maintenance team has or the perception, which is something wrong, that the maintenance team, the main task of the maintenance team is to prevent the failure. That's a perception, but actually the reliability-centered maintenance focus on the consequences of the failures, because based on the studies done mainly by the aviation and the naval industries, where their losses from the maintenance problems are huge, including lives and equipment with millions and so on, and some disasters in the world history and so on. So they found that maybe between 11 to 20% of the failures are related to age, and most of the failure prevention mechanisms we are using are targeting the aging. It's based on the time, not based on anything else. So they found that it's nonsense to do all these maintenance activities, and actually the failure still happens. So that's a big problem. So if I do a lot of maintenance activities, I do a lot of expensive activities, and at the end of the day, failure happens randomly. So I cannot correlate between the maintenance activity I'm doing and the failure that happens. That's a main focus in the reliability-centered maintenance. So reliability-centered maintenance focus on the consequence of the failure. So what happens due to this failure? And if we try to minimize the consequence of the failure, so we can let the failure happen and we can let it take its time, but the consequences on the production and on the operations and on the environment, on the risk, on the safety and whatever is minimum or negligible or does not exist, so you can let it fail normally. So failure, first of all, we need to focus on our perception of the failure prevention. So failure prevention usually means that we do some restoration action before the failure occurs. So to reach to the conclusion of before the failure occurs, we need to reach to a moment where we know that the equipment is about to fail, and in just the last maintenance before this time we had set for or expected that the equipment will fail in, we will do some restoration activities, that we will change some part or make overhauling or replace the greasing or whatever we can do. We will do it based on that we had detected the time. This detection of the time comes from two ways. Either it is merely time based or operation times based, and based on this it will be we need to record the actual operation hours, calendar hours, number of operations, and after recording them we need to compare them to some standard time or number of operations we had achieved from somewhere. So in a moment we will tell where we can bring these values from. On the other hand, we rely on the equipment condition, but this will depend if the workplace adopt the condition-based maintenance, and we can measure the time for till the failure using vibration measurement, using sound ultrasound measurement, or whatever analysis we do, and we know that this equipment is about to fail, and when this equipment is about to fail, we are going to do this maintenance before, when it is nearby or approaching the failure, and at 70% of the condition, 80% of the condition, whatever is our plan or our the methodology we had adopted for the condition monitoring system, or we will plan for just directly the next stoppage, we will stop the equipment and do it. So we handle this extensively in our trainings on Udemy for Secrets of Building a Maintenance Program in Arabic and English. You can join us and you will have a lot of insights and a lot of actual examples and practical examples to apply this. Okay, so the other hand is to relate the equipment aging and the maintenance cycle. As we said, the aviation industry had studied thoroughly, and they found that there is no correlation except between 11 and 20%, 11 in the aviation industry and 23% in the naval industry. And that's the correlation between the equipment aging and a failure that happens. The others are random occurrences of failures. Okay, so the main three sources we get some correlation between aging and maintenance cycles are the operation and maintenance manual, where usually there's a fixed time for operation or some indication. For example, the pressure around the filter had increased, the coolant condition had changed, so we are doing some analysis for the coolant and then or checking the level of the coolant, and then we are taking some maintenance action. But still, he is putting it based on time. So even if after 6 months this didn't happen, you just need to change the coolant or change the lubricant or whatever. Also, the maintenance, usually the default mentality of the maintenance team likes to follow this because it's easier to follow an instruction telling you based on time do this and that and don't chase or analyze or something like that. It's easier. But on the other side, in some regulatory environment of maintenance, you need to apply strict time-based maintenance or number of operations maintenance or strict inspection and analysis and so on to reach to when you will do this maintenance. Okay, this all depends on the consequence of the failure. So this regulation came from the consequence of the failure. If it is related to fatality, to health, safety and environment, or a high cost from the failure or something like that, so you need to strictly follow the timing. But actually this is not the case, because in many conditions it's not regulatorily, but we change parts that we don't need to change and still the failure happens. Also, the manuals from the operators, after that we had inspected them and used their timing. It comes the maintenance team experience from other work locations or from our nearby companies or workplaces, and also comes the workplace experience which build up with time. But that's the sources where we correlate the maintenance cycle and the aging of the equipment. Actually, they are not correlated, but we try to make some correlation with them. So usually aging is not the magic answer, as we had said in the aviation industry, and because the reliability centered maintenance already had been standardized from the aviation industry. That's the reference SEEJA 1011. That's the standard of the reliability centered maintenance methodology of analysis and so on, that was created after a huge analysis from the aviation industry. And mainly it focuses on the consequences of the failure. You need to consider this failure or even partial failure or something of a high value, that we need to take action in case that it's having a high consequence. And then this consequence I need to compare to the maintenance cost. This comparison will tell you that what I am doing this maintenance, it's visible to do this maintenance or it's nonsense to do this maintenance. There's a very important note here at the end of this talk that please, don't add a maintenance activity because you need to close the record of the maintenance activities. Because some failure happened, then we need to take an action based on this failure that happened. So we will add some maintenance task. We will reduce the maintenance task. We will add some inspection point and so on. Regardless of analyzing, this will add a value to prevent the consequence of the failure or to prevent the stimulated effect or the external environmental factors that stimulate or motivate these failures or not. So it needs to be analyzed first, not an action to add it to the report and then close the report. Because on the next failure report, you will do the same. On the third failure report, you will do the same, and so on and so on. Okay. I give you one live example that once upon a time there was a card with a lot of PLC cards and sensors and or receivers for sensors from the field and so on, and some failures started to happen. So someone said that, okay, because there's some dust accumulation, we need to clean the cards. So they started cleaning the cards, and this cleaning while the cards are in location or in their boxes or something, or in the rack, something like that, had deepened the dust insertion inside the cards, and failures increased. So someone decided, okay, we stop the plant for a complete day and we take all the cards out, we clean them thoroughly and return them back and see if this happens. The problem that premature failures started due to installation started to occur and so on. And at the end of the day, the conclusion was to prevent the dust, to make it an isolated air-conditioned room, to prevent totally the natural air and natural dust from entering the room and full with dust and maybe particles of some waste or fumes from the production to enter the room. So that's an action to prevent the motivator for the failure. So it's not cleaning the cars, it's preventing the dust from reaching the cars itself. So that's we need to focus on these motivators. Maybe a loose screw, a cracked base, induced failure from a nearby failing equipment, leakage of air, of liquid or gas or something like that, some human mistakes and so on. We'll study all of this while we're in our journey to prepare for our reliability-centered maintenance. You can make a shortcut by joining our trainings, as we had said. Okay, so all of this help us to change our mentality regarding the equipment failure consequences, and why reliability-centered maintenance focus on the consequence rather than focusing on the real failure itself. Okay, in conclusion, we need to understand that adding a new maintenance task is not the solution to our maintenance problems. And you can join us in our trainings. You can ask even for coaching and maintenance service directly from our site. You will find the links in the post or in the description of this video, that you can order directly from our online store some maintenance coaching or maintenance consultancy online, small sessions that will enable you to take your maintenance to the next level. See you in coming insights from Simple Ways for Maintenance.